Hello everyone. Today we will be taking a closer look at RDBMS and relationships. Before we dive into that, let's quickly recap about our previous video on DBMS. DBMS stands for Database Management System. It's a set of software tools to manage database. It serves as an interface between a database and its end users or a programs, allowing the user to store, retrieve, update and manage data. Data is stored as a files. Examples of DBMS are Microsoft Access and XML. Let's dive into RDBMS. RDBMS stands for Relational Database Management System. It's a type of DBMS that is based on relational model of data. In RDBMS, data is stored in tables. Each table consisting of set of rows and the columns. The columns represents attributes of data while the row represents individual records. In this example here, we have a student's table. Every column representing attributes of a student like roll number, name, age, and every row representing individual instance of a student, or you can say every row representing individual students data. So the key differences between the DBMS and RDBMS are DBMS, it manages the database, it allows the user to store, retrieve, update and manage the data, and it stores the data as a files. The example of the DBMS are Microsoft Access and XML. RDBMS, it's a type of DBMS. It is based on relational model of data. Data is stored in tables. And the examples of the RDBMS are Microsoft SQL Server, Oracle, MySQL. Let's go to relationships. Relations are the fundamental building blocks of relational database. They allow you to store the data by organizing it into a tables and establishing a relationship between them. In easy words, we can say relations helps us to store the data in separate tables. There are three types of relationships: one-to-one, one-to-many, many-to-one, and many-to-many. I want to stress here that it's very important to understand the relationships and how the data is stored in separate tables in order to understand further database concepts. One-to-one relationship. A one-to-one relationship is a type of relationship in which each record in one table is associated with exactly one record in another table. Let's take an example. We have two entities here, customers and emails. So each customer can have only one email, and then single email belongs to only one customer. Let's take another example. Persons and Aadhaar cards. Each person can have only one Aadhaar number, and then the single Aadhaar number belongs to only one person. Let's visualize the data. We have two tables here, customers and emails. Every customer is associated with one record in the emails table and one single email associated with one customer. A question can rise here: why we need to separate this data into multiple tables? Let me explain this. By keeping a sensitive data of a customer inside customers table, this maximizes the risk of data breach. That is, any user who has access to customers table can able to access the confidential data. In order to overcome this, we can separate the data into two tables and establish one-to-one relationship between them. RDBMS provides security by restricting access to the table for a specific users or roles. By doing so, it helps to minimize the risk of data breach and ensures that confidential information is kept safe. Overall, using one-to-one relationship in RDBMS provides security. One-to-many relationship. A one-to-many relationship in which each record in one table can be associated with one or many records in another table. Let's see an example. Customers table and the customer's address. One customer can have many customer address. The same way, one customer can have many orders. So the relationship between the customer and the address table is one to many, and the relationship between the customer and the orders are one to many. Let's visualize the data. We have a customers table with the data and the orders table with the data. The customer 111 has 2 orders in the orders table. That means one customer has many orders. So the relationship between these 2 tables are one to many. Many to one relationship. This relationship is the inverse of one to many relationship. That is, each record in one table is associated with one or many records in another table. Let's check an example. Customer address and the orders. Let's check the relationship between the customer and orders. If we see from the perspective of the orders table, that is, many orders belongs to one customer. If we see from the perspective of the customer address table, many address belongs to one customer. Let's visualize the data. We have 2 tables, customers and the orders. There are multiple orders belongs to one customer. If we see from the perspective of the orders table, we have many orders which are associated to one customer. So this is many to one relationship. Many to many relationship. It exists between the tables if a single record of first table is related to one or more records of second table, and a single record in the second table is related to one or more records of the first table. Consider 2 tables, student and courses. A particular student may enroll in one or more courses, while a course may have one or more students. To implement a many-to-many relationship between these 2 tables, we would typically create a third table known as junction table, which is student courses. This junction table acts as a connector between the 2 tables, allowing us to track which students are enrolled in which courses and vice versa. Let's visualize the data. We have a students table and courses table. One student enrolls multiple courses and one course enrolled by multiple students. So, relationships are an essential aspects of RDBMS. In RDBMS, data is typically organized into the tables. In our example, we have 2 tables, one for customers and one for orders. By establishing a relationship between these 2 tables, we can link each order to the corresponding customer who placed it. This allows me to retrieve all the orders along with the customer information. Let's see an example. By using this simple SQL query, I can able to retrieve all the orders along with the customer information. Overall, relationships are critical in RDBMS. It helps us to organize, manage, and analyze data more efficiently. The most popular RDBMS are Microsoft SQL Server, Oracle, MySQL, Postgres. I request everyone to like this video and subscribe to the channel. In the coming videos, we are going to talk about what is Microsoft SQL Server and what is SQL and lot more. Stay tuned. Thank you.